Here are the 3.5 notes, transformations of functions. This is page 1. In the past, I have gone through graphing these. You've had to sit there and watch me. That didn't seem like a worthwhile use of your time. So I've got the graphs on here that were generated in Desmos. It's important that you understand how the transformations work. So as we see different functions, you can transform those and describe the transformations. So our parent function right here, f of x equals x squared. And let's go ahead and color coordinate. It's called the parent function because nothing has been done to it yet. We haven't messed around with it. We haven't moved things. The parent function always has that 0, 0 point. Let's see, there we go. Close enough. Okay, which we can call the anchor point. That helps us when we start moving these left, right, up, down, everything else we are doing. Okay, and so if we take a look at that function, f of x equals x squared, I plug in 0. 0 squared is 0. I get that point 0, 0. Because this is a standard parabola, it is always going to go over 1, up 1 to a point on the curve. That's not, I didn't hit that right. Over 1, up 1 on the right-hand side. Over 2, up 4, both directions. It's a pretty standard parabola. Okay. Next one we want to look at is this g of x equals x minus 3. And so take a look at the values here. So right here I have a vertex that has moved to 3, 0. And over here I have a vertex that has moved to negative 5, 0. Matching up with the equation, here's our g of x, x minus 3 quantity squared. That moves it 3 to the right. And I once had a student in class say that whenever I'm messing with the x does the opposite. Pretty sure they were talking about a relationship, but we are going to use that here in terms of our transformations. So that x minus 3 actually moved our graph 3 to the right. And so here's how we want to think of that transformation. We have g of x. This may look familiar. This is written in the form x minus h. Notice that that minus there precedes the h. So if our h is positive, this ends up moving to the right. If our h is negative, it ends up moving to the left. So this moves h horizontally. Whenever we make that adjustment to the x, we move along that x-axis to the left or to the right. So let's take a look at our other one here. We have got this graph that has moved 5 to the left. Let me make that curve a little smoother there. There we go. And so we have got our vertex right here at negative 5, 0. That is this equation. And let's just make sure that it matches what we were working with before. So we've got h of x equals, what does that say? X plus 5 quantity squared. Again, the parent function that we are working with is that square. So I want to write this in x minus h form. So this is going to move negative 5. H equals negative 5. So this moves us horizontally 5 to the left. Okay. Example 2. So we have got a cube root function. So take a minute, because this is not one that we see a whole lot. So you may not be as familiar as some other ones. Here's our parent function, our h of x. Didn't like that. See if I can go 2 curves. Yeah, that'll work. Notice this hits this point, 0, 0 again. There's our anchor point. Also goes through the point, 1, 1. And negative 1, negative 1. There is our parent function. F of x equals the cube root. This time when we make an adjustment, it's happening after the function. So take a look at this one. G of x equals cube root of x plus 2. Now notice that plus 2 is not under that cube root with the x. We are not making that adjustment to the x. We are adding on after we complete that cube root. So we're going to plug in a number, find the cube root of it. Once we get our answer, our y, we're going to add 2 to that. This is going to move everything up 2. So if you think about it, we're adding 2 to the y each time. So when I plug in x equals 0, my y has moved up 2. When I plug in x equals 1, that y has moved up 2. And when I plug x equals negative 1, my y has moved up 2. So that plus 2 after the fact is going to be a vertical transformation, a vertical shift, a vertical translation. Okay? So the way we're looking at this is g of x equals our f of x function plus 2. We used 2. Let's back that out and use the value you're going to see. F of x plus k. And so I should rewrite this up here so that this matches. This is our g of x equals f of x minus h. F being our starting value, h being our adjustment to the x that happens within the function. Down below, we have got that adjustment happening after the function happens. So right here, h of x equals cube root of x minus 3. Here is that graph. Everything gets moved down 3 from that original graph. So we have that anchor point here at 0, negative 3. When I plug in negative 1, I get negative 4. And when I plug in positive 1, I get negative 2. It's taken the whole graph and moved it down 3 points. Sometimes it's a whole lot easier for us to just manage those whole number points where we can really see what's going on.